Hi, my name is Oktay. Welcome to today's video about the giant planet Neptune and its moon Triton. This is a picture from the Voyager 2 spacecraft of the 8th planet Neptune. And this is an ice giant at a distance of 30 AU. 1 AU is Earth's sun distance of 150 million kilometers. So the distance of Neptune from the sun is 4.5 billion kilometers. Neptune was already observed by Galileo Galilei in 1612, but he couldn't identify this object as a planet. So it was discovered by Johann Gottfried Galle in 1846. And one feature of Neptune is this great dark spot. This is how Neptune was discovered. It was predicted by the mathematician Hubert Le Verrier. He recognized that the perturbation of Uranus orbit or Uranus motion. And in this picture you can see if this is Neptune, dark blue, and light blue is Uranus. And if Neptune is ahead of Uranus, then you get an acceleration of the planet Uranus. And after Uranus has overtaken Neptune, then it is slowed down by Neptune and you get a deceleration. This is Earth compared to the planet Neptune. Neptune has a diameter of 49,244 kilometers. That's 4 times the diameter of Earth. It has 17.1 times the mass of Earth. And surface temperature is minus 201 degrees Celsius. This is a comparison of Uranus and Neptune. Uranus is the bigger planet by size, but Neptune is the bigger planet by mass, with 17.1 Earth masses compared to 14.5 of Uranus. And since Neptune is further out, it has almost double the orbital period of planet Uranus, with 165 years. This is the NICE model that explains the formation of the solar system. And these 4 circles are the 4 giant planets: Jupiter in green, Saturn orange, Neptune dark blue, and Uranus light blue. And you can see, according to this model, Neptune used to be between Saturn and Uranus. Then Jupiter migrated inwards because it interacted with the existing dust disk. But then it was caught in a resonance with Saturn and was pulled outside, and in this process Neptune was pushed over the orbit of Uranus to today's position in the solar system. And today there's a near 5:2 resonance of Jupiter and Saturn. This is another picture of the planet Neptune from Voyager 2 spacecraft. Shows the dynamic storm systems and the great dark spot. This. And you can see further south, this structure is called Scooter, which is a white cloud. And you can see the small dark spot, which has disappeared in 1994. This is a closer picture of the great dark spot of planet Neptune. It is an anticyclonic storm with a size of 13,000 by 6,600 kilometers. And this spot shifted from north to the south. That's the difference of this great dark spot compared to the great red spot of Jupiter. This spot disappeared in 1994, but new spots were found. These are images from during the rotation of period of 16 hours of Neptune. It has an axial tilt of 28 degrees, and you can see these bright patches are methane clouds. One difference between Uranus and Neptune is Neptune has more internal heat than Uranus. This is a close-up of the clouds of the planet Neptune from the Voyager 2 spacecraft. And you can see the clouds have a vertical relief with structure and shadows. These are pictures of the springtime of planet Neptune from Hubble in the years 1996, 1998 and 2002. And you can see the south is getting brighter. Each season on Neptune lasts 41 years. This is a picture of the internal structure of Neptune. It has a density of 1.6 grams per cubic centimeter. Its magnetic field is tilted at 47 degrees to the rotation axis. You can see the top layer of gas and the molecular hydrogen layer underneath, a layer with water and ammonia, and the rocky core. Image of the James Webb Space Telescope of Neptune and its rings. There are bright patches in the south. These are the methane ice clouds. The rings of Neptune were discovered in 1984. This is a composite image. The material of the rings is dark. It could be ice particles with organic compounds. This is a picture of the system of Neptune's rings. It has 5 rings: Gale, Le Verrier, Lassell, Arago, and Adams. The rings could be made from collisions of moons. And like with the other giant planets, the rings have shepherd moons. For example, the moon Galatea. There's something special about the Adams ring. It has arcs, 5 arcs. They are called Fraternité, Égalité 1, Égalité 2, Liberté, and Courage. And it is not clear how they were formed. This is another James Webb Space Telescope image of the planet Neptune. It has 14 moons. The biggest moon is Triton. Second biggest is Proteus. Third is Nereid. Nereid is interesting. It has a size of 360 kilometers and average distance of 5.5 million kilometers. What's interesting is its high eccentricity of 0.75. This is an animation of Neptune's inner moons. This is a false color image of planet Neptune. It shows the structure in the atmosphere of this planet. This is the second biggest moon, Proteus. It has a size of 420 kilometers, orbital period 1.1 days. And it has a big crater named Pharos with a size of 250 kilometers. This is a picture of the orbit of the biggest moon, Triton, which is here. It has a size of 2,710 kilometers, so that's still smaller than Earth's moon. Its distance is 354,800 kilometers. Triton was discovered in 1846 by William Lassell, and what's special about this moon is its retrograde orbit. Triton is bigger than the dwarf planet Pluto, so it could be that this used to be a dwarf planet which was later captured by Neptune. The surface contains nitrogen and water ice and has cryovolcanism. The reddish color could be from solins. Solins are chemical reaction products of nitrogen with hydrocarbons in your UV light. This is a picture of the structure, potential structure of Triton. You can see here the fumes from the cryovolcanism. And there could be a subsurface ocean potentially with life on moon Triton. This is a computer montage of the giant planet Neptune and its moon Triton. Triton is spiraling towards Neptune, and once it's closer than the Roche limit, then this moon will explode, which will probably be in 3.6 billion years, and this would give Neptune a new ring system. This is the artist's concept of the tiny moon hippocamp, which was discovered by Hubble in 2013, has a size of 35 kilometers, and it could be formed from the debris which was ejected from a moon Proteus by an impact. Neptune is the dominant object in the outer solar system. All other tiny objects most of them are in orbital resonance with Neptune. For example, the Plutinos, the Cubevanos, and Tutinos. And the most prominent of these objects is, of course, dwarf planet Pluto. It is in a 2 to 3 orbital resonance with Neptune. So in 2 orbits of the dwarf planet Pluto take the same time as 3 orbits of the giant planet Neptune. That's why Pluto never comes close to the giant planet Neptune. Other stars can have also Neptune-sized planets. This is a diagram of these planets. You can see different colors, different detection methods of these planets. X-axis is the orbital period of these planets. Y-axis is the mass of these planets. And you can see there is a gap within these 2 black lines. This is called Neptunian Desert. And according to the theory, in this gap, there are no more Neptune-sized exoplanets in close proximity to our star, because these planets lose their atmosphere and then become rocky planets. Or you can see there's the red X. So this is one exception. That's the planet NGTS 4b. And possible explanations are maybe this planet is very young. It has not yet lost its atmosphere, or maybe this planet has a very massive core. This is a very large telescope image of the planet Neptune. And this is a nice animation of planet Neptune from its seen from its moon Triton. In the background, you can see the sun. That was today's video about the giant planet Neptune. Thank you for watching. Have a nice day. Bye bye.